Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's TechStrong Learning Experience brought to you by AWS and Snyk. My name is Jared Harris, and I'll be your host for today's discussion. Before we get started on this exciting panel, I've got a few housekeeping notes. Today's event is being recorded, so if you miss any of today's discussion or you'd like to share with a friend, the on-demand will be recorded and made available to you shortly after the workshop concludes with a link to access as well. If you have any questions, we'd like you to submit them on the Q&A tab on the right side of your screen. This is also where you'll find the chat tab. We want you to engage with our speakers or your fellow audience members, share your thoughts, or just tell us where you're tuning in from. Finally, at the conclusion of today's Immersion Day, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of the program. Let's go ahead and kick off today's Immersion Day workshop, Secure Your App Modernization Initiatives in Development. Today we're joined with David Scott, William Donnelly, Raj Jarapatula, and Yash Kimani. It's my pleasure to turn the program over to you, Raj. We'll go ahead and get the introduction started, and I'll turn my camera off. Thank you.
Thank you very much, Jared. Hello, everyone. Good morning, good afternoon, good evening, wherever you are. So today, I have an amazing team here from Snyk, Presidio, and HashiCorp. My name is Raj Jarapatula. I'm a Senior Partner Solutions Architect at AWS. William?
Yeah, my name is William Donnelly. I'm a Principal Architect here at Presidio, based out of the Austin area.
Yes.
Go ahead, David.
Hi, everyone. Yeah, thanks. Hi, everyone. I'm David Schott. I'm a Partner Solutions Architect at Snyk, normally based out of Brooklyn, New York, but I'm at the Snyk Boston office today. Good to be here. Thanks.
Thanks.
Yes.
And I'm Yash Kimani. I'm a Solutions Engineer at HashiCorp, based out of the Washington, D.C. area. Pleasure to be chatting with all of you today.
Great. So with this, let's get started. So I have a couple of slides there. We will go through what's the agenda, what we're going to do today. Today you'll have access to like AWS, you'll have access to Snyk, access to HashiCorp. So AWS access is for like almost 24 hours. So feel free to go and learn something new. So when you walk out of this webinar, you'll have whole day access to try something new and learn on AWS, HashiCorp, Presidio, and Snyk. So let's get started. Let me know once you see my screen. I am going to do the presenters mode. One moment.
We see the blog.
We see DevSecOps cycle coverage. There we go. Okay, never mind.
Okay. Yep. Thanks for your patience. So let's get started. As I mentioned earlier, my name is Raj Jarapatula. I'm a Senior Partner Solutions Architect at AWS, and I work with various ISVs, independent software vendors, and AWS partners, specializing in CloudOps and DevOps and SecOps to develop joint solutions and accelerate cloud adoption on AWS. So today, my speakers are David from Snyk, Yash from HashiCorp, and William from Presidio. So we will be talking and listening to what the experts have to say today. And this is the agenda today. So I'll just talk a bit about what AWS resources you will have access to today. You will also look at how to get into AWS console, and then some best practices on how to use the accounts. These are like production accounts. So when you use it, please make sure you use it only for what is needed for you to do your job and learn something new. So please be mindful of spinning up big clusters or like big resources which you do not want to use, because this is like a cost to AWS. So please be mindful about what resources you are using today. Then I will hand it over to William, who will talk about Presidio, some of the solutions, and then to Yash, who will talk about HashiCorp, and then finally to David, who will walk through the lab, and finally we'll also have Yash talk about the HashiCorp lab. And at the end, we'll have a survey. This is very important for us to understand like how the workshop went, what issues you have. So please do not forget to let us know what issues you had and what you like, what you didn't like, so that we can work on it and come up in a better way in our next webinar. Some of the housekeeping items, I think I did mention about production accounts. So today you'll have access to AWS production accounts. So as I mentioned, please be mindful about what resources you're using. So spin up only things that you need to learn that you need to do the workshop today. And if you want to play with something, learn something new, please do that. But please like spin up like small EC2 instances just for you to learn, not spin up like a big clusters. That will be like a big charge or cost to AWS. And finally, event survey. We already talked about it. So please do fill up the event survey. So once you get into AWS account, right, the way I will give you an email URL, you need to put in a code, which will give it to you. So what happens is once you log in, you will have to give your Amazon.com email. Like if you already have Amazon.com email, you can use that, or you can use your personal email. You'll get a one-time password. You can use that password to authenticate that, yes, you are the user, and then you will get access into AWS. And now I will show you how to get into AWS and how to play using this whole workshop, how to use the whole workshop. So one best practice I would like to say is like open a new browser in a private mode, incognito mode, because if you already have AWS accounts open in the browser from your work or from your personal account, that might conflict with the workshop today. So some screens might work, some screens might not work. So we'd want to avoid that. So my recommendation is to go and open a private tab in incognito mode, and then you should be able to get into AWS without any issues. So these are all like temporary accounts. So end of the day, once you are done, right, all these accounts will be terminated. So don't worry about if you want to shut down something, it's good. If you don't shut down and keep it running, we will take care of it. We will shut down everything for you. So enjoy, happy learning. We want you to walk out from this webinar learning something new, trying something new, so that you can let us know what you learned and how helpful it was, what we could do better, all those in the event survey. So can someone put in the link for the event engine so that we can go and start playing with it?
Yeah, you'll see it in chat as a sticky blue colored link at the very top.
So click on that dashboard event engine. One moment. The URL doesn't open here, so I have to go and manually copy here. So this is the link that you're supposed to open. So this is in the chat. Let us know if you have any issues with this. And then there is a code which starts with like 5DB5. So here you go and enter the code here, accept terms and login. I'll make this big. So since I am already logged in, I'm directly getting into the screen where you see that you have AWS console SSH key. But for you will have three options. You will see enter your personal email. Okay, where is the code? Okay, code is here. So you have to like either have an Amazon.com account, or you can enter your personal email. I have employee access, so I entered as an employee already. So personal email, and then you get a one-time password. So I will give like 2 minutes for you to go and get into the AWS account, and let me know in 2 minutes if you're able to get it, or if you have any issues. We have all the speakers on the call and technical people on the call who are going to walk you through if you have any issues. So now here, I will go and say AWS console. So I am in US East 1 region. So please stay in this region throughout the workshop so that you don't have any issues. This workshop works well, and it is set up for US East 1 region. So please do that. And here I can say open console, and this should automatically take me to AWS. So if you are seeing the AWS console for the first time, this is how it looks like. If you are not seeing it, if you already used it in your work environment, it might be slightly different from what you are using because your production account at your company or your personal might be slightly configured different. Can you please paste the event code here? I think I just pasted there, but I can paste again. So once you come in here, you have access to all the services here, or you can go and search anything that you want to do. You want to do code pipeline. We have code pipeline, you just click on it. So everything is on the search bar. You can search here, and you use the search bar to search, and then you can get into AWS. So this is what I want you to do before we start with the workshop. Anybody has any issues getting into AWS with their one-time password or Amazon.com password, please put up in the chat. I will be watching the chat in the meantime. Then I will hand it over to William to go through the Presidio presentation. Then we will have Yash, and then we will have David talk about the workshop. We'll go through the workshop, and this is like a hands-on workshop, so you can do with us or you can just watch. Then at the end of the webinar, we'll give you enough time, like 24 hours. So I'm seeing all good. So good, everybody's in. So great. So I think this is good. Good to hear. So I will hand it over to William from Presidio to continue with the presentation. But don't forget to do the event survey. Yash, do you have the link for the event survey? Can you please place that?
Yes, I'll add
You're
that.
having issue. Somebody's having issue with the copy URL. Okay, let me see. I can copy link and this. Yeah, can you directly click on the link, because the copy URL doesn't work directly. I think they want the not the access code. They want the event engine login URL. Yes.
Yep, that's there also. Just a couple of messages higher
Yeah,
where it says the URL. Do you see that?
I can also put in there.
Thanks.
Okay. So, yep. Yeah. So, William, all yours. I'll hand it over to you. I'll stop sharing, and then I will be watching the chat Q&A and make sure that you are able to access everything that is needed for you to do and learn something new. Thank you.
All right, thank you. All right, thanks again, everybody, for joining today. We're just going to talk a little bit about Presidio and the capabilities that we have here. So who is Presidio? Presidio is a global digital services and solutions provider, accelerating business transformation by modernizing and securing our clients' information technology. Here at Presidio, let's go here. Here at Presidio, we're a trusted advisor, right? So we're providing clarity to ensure the right tech investment choices are being made for our customers. Additionally, we're a business co-creator, right? So we're defining tech initiative to executive organizational strategies. Along that, we're also digital disruptors, right? So we're on the differentiated use of technology and to support innovation. We're also a service provider with global resources to cover gaps in the capability and accelerate the successful outcomes for our customers. Presidio at a glance, right? So this is a good slide that just talks about us at a glance from overall company, right? So Presidio, we are proud of our 98% repeat purchases, which demonstrates our customers' loyalty, right? And one of the main reasons for that loyalty is because of our 7-to-1 engineer ratio, right? So we have a lot of engineers per our sales ratio there. We are an engineering company who has a sales force behind us. We have over 10 plus years of loyalty with our top 50 customers. Along that, we have, our clients are consuming more types of products and services from us, which speaks to our breadth of expertise, similar to like this workshop that we were doing today. So when it comes to our partners, right, we work with several partners throughout our company. And here at Presidio, we work with all these just like our customers do. Our partnerships can help reduce the noise and confusion, for our clients by providing services around the known integrated workflows in DevOps, Net DevOps, and DevSecOps. We work closely with our partners to bring leading technologies to our customers. And in today's multi-partner innovation content is a perfect example of why you should reach out to your Presidio rep to learn more about how we could help elevate your environment with with today's event here. And with that, I just want to thank you for your time. Just a quick, brief overview of Presidio, and I'll turn it over to David. Thank you.
All right, thanks so much, William. Let me get my screen shared here. Sorry, just one more second. All right, so thanks again, Raj and William, for teeing us up. And again, what we're going to be talking about today in this workshop is deploying infrastructure with HashiCorp and doing that securely with Snyk. And it's definitely a challenge to do this, especially at large organizations at scale. So please do consider bringing in a partner like Presidio. But before we get into the webinar, what I'd like to do is say a few words about Snyk. So without further ado, again, I'm David Schott, and I'm a partner solutions architect here at Snyk. And I'd like to take just a few minutes to introduce you to the Snyk developer security platform and show you how we help customers to create, build, and deploy secure applications. Now, what you'll see in this presentation is that the way that we do this is by helping developers build securely and helping the security teams to guide the developers. Now, our founders recognized when we were founded back in 2015 that development practices had changed, but the security tools had not. And since we were founded, the number and the scope of security issues that developers have to deal with has only increased. So we're seeing things like how software development is moving faster than ever. So we need developers to understand how to build secure applications and to give them feedback as they're working without slowing them down. We're also seeing that the software supply chain is more complex than it's ever been. So we need to give developers visibility across all the applications that they're maintaining and the entire software supply chain that those applications are composed of. And then also the cloud is part of the equation now. It's something else that developers have to manage. So we need to understand all the code in our application and the life cycle all the way to the cloud and from the cloud back to the code. Now, the problem is that unfortunately, the traditional tools and security processes for applications hasn't kept up with all these changes. We started with two separate audits late in the release process, one for our application and another one for infrastructure. And we were using tools built for security experts. And now everyone says they've shifted left, but what this usually means is they've taken the same code auditing tools and put them in CI tests, but they're usually some variant of the same security experts tool that runs after the application is built. And they still require that same security expertise. Many have started scanning in the IDEs now as well, but developers expect these scans to be fast, and traditional application scanners are far too slow. So they fix that by providing a slimmed down version of their tool to scan in the IDE. And the problem here is that developers might think they've done something right, only to find out in a later step that they have to go back and fix things. And the result is that the beautiful infinity loop that symbolizes the goals of DevOps and DevSecOps is broken. The developers on the left are frustrated because they run into too many security roadblocks late in the cycle, or they're given too many security issues to deal with from all these different tools, and they don't know where to start or what the most important thing is to tackle first. And then the security teams on the right are frustrated because they're far outnumbered by developers and they're having a hard time keeping up. On top of this, there's a disjointed collection of security tools attempting to help with application security, but they produce too much noise to deal with. So to handle these problems, we need a different approach to application security. We need to test continuously from code to the cloud, and we need to focus on fixes because we can't send developers out searching for details on every security ticket because they'll never come away from that fast enough. And we need a holistic view of our applications in the cloud to provide context and prioritization for issues. Now, this is where Snyk comes in. Snyk enables you to keep up with the speed and the scale of development by turning developers into people who understand and love to create secure applications. Now, Snyk works for all your developers. So that means your application developers, platform or cloud developers, whatever you might call them. And it's going to work throughout all their code. So their application code, their dependencies, their containers, and their IAC or infrastructure as code. And it's going to work in all the tools they're already using as part of their everyday workflow. Snyk is there helping your developers prioritize and fix security issues, and we sprinkle in engaging security content along the way. And it's the complete, comprehensive, actionable results of Snyk all the way through, not some trimmed down version of Snyk's tools. Now, DevSecOps doesn't stop once the app is deployed. You need to know the running state of your cloud, and the cloud provides important context back to developers to help them to continue to improve the security of their applications. Now, Snyk proactively secures the cloud through IAC scanning in your IDE, which helps you fix far earlier in the process at a much lower time and cost than fixing those same misconfigurations post-deployment or during the build process. And we also provide simplified visibility and governance across IAC from code to cloud with a unified policy engine and one clear set of rules, helping you avoid rework or inconsistencies in the security and compliance posture between your IAC and your cloud. And then we enable developer-led remediations at scale by remediating in the source code, tying cloud resources and their issues back to the IAC files that you're using to deploy, and enabling cloud issues to be fixed in code. So for the security team, Snyk enables you to go from a state where you're manually stitching together many different tools and triaging and prioritizing results from all those tools, and then attempting to manage a developer's work through tickets, to a new world where we're empowering developers in their existing workflows, we're automating the triage and prioritization process, and we're governing security through policies and automation across all your apps and all your cloud deployments. Now, Snyk's developer security platform brings all of these capabilities together. We're building a platform that provides all the teams involved in building and deploying software with an end-to-end security workflow from code to cloud and from cloud back into the code. A platform that seamlessly integrates security into the full software lifecycle so that developers can build secure applications, so that DevOps and platform teams can support developers and design secure environments to run these applications. And we're enabling the security teams to provide the right level of visibility and guardrails to govern the process. Now, today, Snyk covers your custom code, your open source packages, your containers, and your cloud configurations and cloud posture. And we also partner with a wide range of tools within the developer ecosystem. But ultimately, there will always be more areas to cover, more tools to integrate with, and new development workflows to support. And because of that, our platform was designed to be fully extensible so that new tools can be easily plugged in, either by Snyk or a partner such as HashiCorp, Presidio, or AWS, or even a customer like yourselves. And this extensible architecture enables us to deliver the best developer experience, ensuring that developers have a holistic view of their application together with the deep security intelligence that they need to be able to take action, while also educating them about security risks as they work. And with all of that together, Snyk enables you to close the loop on the DevSecOps path and deliver security from code to cloud and back. Now, today we're going to be focusing on two areas, which are the Snyk infrastructure as code product, and we're also going to be looking at Terraform Cloud from HashiCorp. Now, I'm going to be talking about Snyk, and Yash is going to be talking about Hashi. And with that, I've got the links up on the screen, just in case you still need them. There they are. And thank you for hearing me out. I'm going to hand it over to Yash now to say a few words about Hashi, and then it's going to come back to me, and we'll kick off the workshop. Yash?
Thanks so much, David. Let me share my screen real quick, and we'll get started with a little overview of Terraform. That should be popping up as a screen share right now for you.
You're good.
Excellent. Okay. And what I wanted to do is just kind of walk through the workflow that we'll be using today, show you how Terraform and Snyk work together. For those of you who may be unaware or unfamiliar with Terraform, Terraform allows you to codify your infrastructure. This enables you to, adopt patterns, strengthen those patterns, and use them in a repeatable fashion. And I'll actually turn off my video because you're just going to be looking at the top of my head because I'm going to be drawing. So, with Terraform, we're going to be codifying our infrastructure. We do this using a configuration language called HCL, or the HashiCorp configuration language, right? And what this allows us to do is describe in a declarative manner what our infrastructure should look like. Now, when we collaborate on code, it's just like writing any other software. We're going to take this piece of code, we're going to put it into a version control repo. Really, there's a repo and branch combination here, right? We're going to collaborate where other developers can come in. They can take what we did, maybe modify something, add some things and so forth, iterate on this, and do this via a pull request, eventually merging. Of course, we know sometimes people will actually just push directly to the branch. Don't do that. But this allows us to collaborate. Now, the way that Terraform Cloud or Terraform Enterprise, if you're using the self-managed product, what I'm describing today applies to both, and I'll describe Terraform Cloud or Terraform Enterprise with this big T. This comes into Terraform into what we call a workspace, right? And when we do that pull request, or we merge it, or we do a push, what happens is there's a webhook that gets sent to Terraform Cloud. And that brings in this configuration that we're working on. There's a lot more to the workspace, including how you instantiate that configuration, right? So you'll see today we set variables to manage our Terraform configuration. So those get set in the workspace. For sensitive variables, they get set in a secure way. So we're going to do this today with the cloud credentials. We'll set those securely. The idea of securing variables applies regardless of whether it's a Terraform variable or it's an environment variable that is used to instantiate a Terraform provider. From there, Terraform does a dry run, which we call a plan, right? So this describes to you what Terraform is going to do before Terraform actually runs it. From there, and I'm drawing it here because this is how we're going to integrate Snyk, but really the run task can be set to run pre-plan, post-plan, or pre-apply, and I'll talk about applies in just a minute. But what this allows us to do is bring in integrations like Snyk that allow, showing my dyslexia, that allow us to, validate that what we are doing is secure and compliant, right? That we're not going to provision something that, for example, is too open with regard to how our security groups look, that, we forgot to turn on encryption for our volume or for blob storage or whatever it is that we are working on. From there, Terraform does a cost estimation, and this leverages the cost estimation API from AWS. And then from there, we also do a policy check. So Terraform Cloud supports the Sentinel policy as code language. So just like we codify our infrastructure using HCL, we can codify our policies using Sentinel or using OPA, right? So that policy check happens. And finally, if everything is good, Terraform does an apply, which actually pushes, what it is that we had codified in that configuration to our fluffy clouds and our different AWS regions. right? Now, in order for this to happen, there are a few things that need to be valid. Just to kind of emphasize this, the plan has to pass. It has to be valid, right? The run tasks that we've configured as mandatory, those must pass. And then our Sentinel and or OPA policies, those must also pass. If those all pass, we actually are able to apply and push things to the cloud. The way that Terraform allows you to iterate, what comes back from this process is a state file that describes what it is that Terraform actually provisioned. And part of the way the Terraform cloud works is this also is secured. So when depending on what it is you're provisioning, you may end up provisioning or handling values that are sensitive. So for example, if you're generating, a private key as part of your Terraform provisioning activity, or maybe you're standing up a database like an RDS instance, and a password comes back from that, right? Values like that need to be secured, so they get secured in state through Terraform Cloud. If we take a step back real quick and think about the value of this entire workflow, right? Why should I do this? Again, the intent is to be able to provision infrastructure at scale, to be able to do it in an efficient manner, right? So this approach where we can codify, and I've given a very select overview of Terraform Cloud in the interest of time. There's other things like RBAC and the private module registry and so forth. But the value of this approach is it allows us to work more efficiently. It allows us to increase our velocity at which we are able to provision, allows us to manage cost, not just in terms of the infrastructure we provision to ensure that it isn't overbuilt, or but also to ensure that we're not having to do remediation because we aren't catching things in the provisioning process. We're trying to address them after the fact, after maybe a vulnerability is identified or data breach has happened, and it allows us to manage our risk, right? Allows us to lower our risk because everything we're doing is secure, is compliant, because if it's not, as we mentioned, that prevents us from being able to actually provision. So this is the workflow that we're going to be using today as part of the workshop. With that, I'll hand it back to David, and he's going to take us through the first part of the workshop.
All right, thanks so much, Yash.
Yeah.
Appreciate that. Fun fact, actually, last week I was using some Terraform in a CI/CD pipeline, and I was deploying this service account. And what I noticed was that every time I ran my CI/CD pipeline, I would keep creating the service account, and that was pretty annoying. So I'm like, okay, how do I fix this? And the solution was right in front of me, Terraform Cloud. If I just simply connect my CI/CD Terraform to Terraform Cloud, I have a very easy way to save state and make that pipeline item potent, which is what I was looking for. So appreciate the background, and we'll see more of that here in the workshop. So this is what we're here for, everyone. Your screen should look almost exactly like mine, whether you're on the left side or the right side or vice versa. It's a good idea to have both windows here so you can go through the content and have the tools like AWS, Snyk, and Hashi in another window on the side. Now, in the interest of time, I am going to go ahead and skip the introduction section here. If you run through this on your own, you can go ahead and look through. It's mostly literature on Snyk and Hashi and AWS. But since you've already heard from all of us, I don't think you need to hear it again, and nor do I want to read paragraphs verbatim to you all. So we're going to jump right into the setup. And just a quick high level, what we're going to be doing here is deploying some actual infrastructure out to AWS using Terraform. And it's going to be insecure. It's going to have some security issues. So we'll talk about those and talk about how to find and fix those security issues using Snyk. And then I'm going to hand it over to Yash, and in part 2 or module 2 here, we're going to bring in Terraform Cloud to add some additional guardrails and governance to the process. So buckle up. Let's get into our AWS consoles and have some fun. So jumping right into the self-guided workshop setup, there's several things that we need to do to make all of this work, and a lot of this has to do with access. We need Terraform to be able to access our AWS environment, and the common way to do this is through AWS IAM, or Identity and Access Management. So scrolling down, I'll just go ahead into the next section. First thing we're going to do is create an AWS IAM user and give that user administrator access. And then later we're going to grab something from that user so that our tools can access the same AWS infrastructure. So here in your dashboard, make sure you have the AWS console open. Here's mine. And there's a few ways to get to AWS IAM. I like to just type IAM right here in the search. And there we have it, Identity and Access Management. Now, if we click Users on the left, we do have a user here with a clever name, Event Engine Overlord. This is kind of a special user that we're not going to use in this workshop. So let's go ahead and add a new one with this button right here. Now, the username can be anything. I'm just going to call them work, if I could type today, workshop user. And we actually don't need to give this user access to the AWS console. The main reason we're creating this is to get an API key for this user. So we can just type a name and click next. And then we will attach an administrator policy directly. Since we don't have any groups to add them to at this point, we're just going to directly give them the administrator access, which happens to be right here. But if you want to, just to be safe, we can search for administrator, and there it is at the top of the list. Scrolling down, we click next, and that's all we need to do. As a best practice, it's a good idea to add tags, but since this is all going to be deleted in 24 hours anyway, I'll skip that and then go ahead and create my user. Interesting. I didn't expect to see someone else in this list, but it looks like we have some shared sessions going on. So I don't think this is going to impact us, but interesting. Whoever created this, you're in my AWS console too. All right. So the next piece, once we have this user created, these are all the steps for the user. Like I said, we're going to create some access keys. And we do that by grabbing them from this new user that we created. So scrolling down here, all we need to do is select the user that we created and then go to the Security Credentials tab. This is where we would normally do things like assigning our cell phone to be the MFA device. But in this case, what we're going to do is get an access key so that an external system like Terraform Cloud can access AWS through this user account using the access key. And let me just scroll down here just to make sure we're in the right place. We are. So we'll click Create Access Key. Now this is a warning from AWS saying there are other, participant 248, thank you for letting me know that that's your user. I don't know how that happened either. Anyway, so AWS is giving us a warning saying, hey, you know, there are other ways to get access to AWS. You should consider these, but we do need this access key. So please select Other and click Next here. Let's go to description, you know, workshop access. I can't type workshop access key. Sure, that's fine. And then we'll create it. And once you create your access key, you're not going to see it again for a little while. So go ahead and put that on your clipboard and put it somewhere safe because we're going to need it later. Personally, what I do is just open a text editor or whatever you have on your laptop where you can store something. I'll just go ahead and put that here. AWS access key is this. Okay. I think it's worth saying that we're going to be using a few different access keys during the workshop today, including a Snyk key that's pretty sensitive to me. But in the interest of security, I'm definitely going to be rotating these keys. So if you see anything on the screen, it's not going to work for you very long. It's going to get rotated. All right, so we're done with our, yes, we have. We're done with our AWS access key. Here it is, it's created, and we have that saved on the side. Next, what we're going to be doing is creating up a workspace, and we're going to be using AWS Cloud9 for this, which is a cloud-based IDE. This is going to help us to pull down some Terraform code that we're going to be interacting with. And there's also a terminal right there in your cloud that we can use to type Terraform and Snyk commands. So let's go ahead and create that environment. If we scroll down, all we need to do is, just like I am, type Cloud9 in the search. And then we get over to the Cloud9 service. From here, we say create environment. We'll say workshop Cloud9 environment. Give it a name, a description, whatever you want there. And then we can leave everything else as is. It's going to spin up a new EC2 instance behind the scenes where this Cloud9 environment is going to be running on. And it's fine to use the default instance type here, the small one. It's plenty fast for what we need it for. And then let's go ahead and create that. Okay, so we've created our Cloud9 environment. We can see that it's creating right now, and this does take just a couple of minutes, but it is there, and we can open it. Really nice to see you here, participant 200 and something, following along. That's nice. That's great to see. Why don't we get a quick heart emoji if for those following along? Make sure everybody's tracking here. Awesome, thank you. Love to see that technology. All right, so our AWS Cloud9 environment is still being created, and just for the heck of it, we could go over to EC2 because it's running on an EC2 instance, and what we should find here is, and we do, a couple of Cloud9 environments running. And if we move to the right, I think they're still initializing, so that's why this is taking just a moment here. So once this Cloud9 environment loads, it should just be a few more seconds. We're going to go in there and we're going to change an important configuration setting in there. So I'll go ahead and move to the next step. A couple of things we're going to do. First thing is that we're going to assign an IAM role to our Cloud9 instance. So let's just make sure it's running. It is, okay. So here's Cloud9. We've got a Cloud IDE. We've got a nice terminal window here, a welcome screen. I'll go ahead and close that. And we've got a workspace, but we're going to get some different code in here in a little while. So we want this Cloud9 environment to run similar to before as an administrator so that it's able to deploy the Terraform code that we grabbed. Oh, it's still there. Okay. We want it to run as an administrator so that it's able to deploy the Terraform code that we pulled down in a bit. So to get this Cloud9 environment running as an administrator, what we do is we create an IAM role. So back over in the IAM console, we go to roles, not users, but roles this time. And then we create a role right here, just like creating a user. Leave this setting unchanged right here, and we're going to select EC2 since Cloud9 runs on EC2, and click Next. And then just like before, we'll go ahead and give it administrator access. Now, ideally, you want to use least privilege, but for simplicity, we're just going to give it full AWS access for the moment. click next, and we'll give it a role name. Let's call it Cloud9 role. That should work. And then I believe we can leave everything else as is. Yes, we can. And then go ahead and create the role. All right, so the role was created. We can view it just to make sure it's there. It is. Next step is to attach this administrator role to our EC2 instance that's running the Cloud9 environment. So again, this is running on an EC2 instance, and we want that EC2 instance to be able to call out to AWS as needed. So let's go back to EC2 and try to find the Cloud9 environment that we just created. All right, so under instances, one of these is mine. Thank you, other participant, for choosing a different name. That helps. Please keep doing that. All right, so this is my EC2 instance that I created earlier. And what we want to do is attach the roles. So to do that, we click on Actions. And then I think it's under, Security. And then we say Modify IAM role. So once again, Actions, Security, Modify IAM role. Click that. And then in the dropdown, we should find the IAM role that we just created earlier. Select that, and then click Update, and that's all we need to do. Just like that, this EC2 instance is now running with a different role. Now, this next step is a little bit hidden here. It's kind of easy to miss this, but this is very important because the way Cloud9 works is it has a built-in, like, temporary ephemeral kind of role, and we need to change a setting here in the IDE so that it uses that administrator role that we just assigned. So to do that, we go into the Cloud9 settings and scroll all the way to the bottom. There is a section here called AWS settings. And in here, there's just a couple of toggles. Right here under credential, it says AWS managed temporary credentials. We want to turn that off. We don't want to use the temporary credentials. We want to use the one that we just assigned. And just like that, that setting is now changed. And our Cloud9 environment is now running as an AWS administrator and able to deploy some infrastructure out to our environment. We can actually skip this step. It says make sure your AWS CLI is up to date. Always a good practice, but since we just spawned this Cloud9 environment, it's definitely up to date. Thank you, AWS, for that. And we can actually skip this EC2 key pairs section as well, because there's an optional part of this workshop that we're not going to do today. And since we're not doing that, we don't need this EC2 key pair. So good news, we can skip this and move to the next section. All right, so now we're pretty much done, I think, with the AWS setup. Now we're going to do a little bit of setup with HashiCorp and Snyk. So this is just an overview. Basically, just need to install a few things and make sure we have the right access. So going into the Terraform setup instructions, there is a section here about the Terraform CLI, about how to install it. But once again, we can actually skip this, because if you take a look and just type the word Terraform, hit enter, Terraform is already installed in this EC2 instance, or sorry, Cloud9 environment. So no need to do this. We already have the Terraform CLI. But we do need to go into Terraform Cloud and get another access token. So hopefully you did some of this before the workshop, but in case you didn't, we'll walk through the whole thing. So we're going to go over to Terraform, and this is going to be app.terraform.io. So I'll open that manually like this. Here we are. This is that project that I was talking about that I was working on the other week. It's not fully working yet, but I'm getting there. Now, when you log into Terraform in the audience, your view might look a little different from mine because I have an existing project here. In your case, if it says welcome to Terraform Cloud like this, then go ahead and select the start from scratch option. And after doing that, create a new Terraform Cloud organization. I have mine named after my online handle here, but you can just go pick whatever you like. And once you have your Terraform Cloud organization, you should have a view at that point that looks fairly similar to mine, just no workspaces. And from there, you, if you haven't done so already, can initiate a free trial. And that is through a button down here by your username. If you click it, it should have a little thing there that says initiate free trial, which you can do that. And then just select the trial plan and say start. And I think that'll give you 30 days access to Terraform Cloud. And also your view as a result will look just like mine. So once you've done all that, we need to create a new workspace in Terraform Cloud. So I'll go ahead and do that. So new workspace. And we're going to select the CLI-driven workflow option, and then give our workspace a name. So we'll call it AWS Workshop, just like the instructions. And we'll go ahead and create that. That's all we need to do is give it a name. Success, workshop created. And if I go back to my home page, we see it there. And now we need, like I was saying, another API token. This is our Terraform Cloud token, and this can be found in the user settings. So let me just find this. I believe it's here. User settings. Yep. So one more time, in Terraform, your user settings are at the top by your picture, or maybe a letter if you haven't put in a picture. And then you click user settings and then tokens. This is what we're looking for. I'll go ahead and delete this other one that I used to practice. So let's confirm that. And create a new one. So this new one, we'll call it, let's call it HashiToken. HashiToken, and I'm going to set the expiration date to 1 day because it's not going to be very useful after this event engine shuts down. So we'll go ahead and select that, generate. And then once you have it, make sure you copy that off somewhere because it's not going to be displayed again. So just like before in your text editor, go ahead and notate what your token is so that we can move on and clear this off the screen. Okay, so that's all I need to do here. All right, next step is moving over to the Snyk side of things. First is to set up your Snyk account, which if you haven't already done, it's very easy. It's really just go to snyk.io and click the create account button or log in if you already have one. It's totally free to create an account. It's also free to use Snyk products, although it comes with a limited number of scans, but still free forever and great for a small organization to be pretty effective with Snyk. So once you have your Snyk account, your view will look something like this when you're logged into Snyk. This is app.snyk.io. And within Snyk, we need to create an access token. Just like within Terraform Cloud, we need to do the same thing on the Snyk side, and it's a pretty similar workflow. So within Snyk, you go to your user account, which is here on the bottom, and go to your account settings. Within your account settings, on the default general page here, it has an API token. You might not have one. If you don't, just click create. Since I already have one, it's hidden here and it says click to show. And I'm going to attempt to hide that from you all. by doing a little trick to put the token that I already have onto my clipboard. That's what that does. You're still going to see it at some point, but at least I don't have to click that button and put it on the screen. But once you have your Snyk API token, again, just put that somewhere for safekeeping. And then we also need to set up the Snyk command line on the Cloud9 environment because it's not there by default, but it's pretty darn easy to install. So to do that, all we need to do is copy and paste this command from the workshop into our terminal window. And once we've done that, we can type the word Snyk. And since it didn't say, error, I couldn't find Snyk or command not found, it's giving us the Snyk results here. We've successfully installed the Snyk CLI. Easy peasy. Further down, we need to authenticate the Snyk CLI. So we want the Snyk CLI here within Cloud9 to be able to communicate with our Snyk account on snyk.io. So to do that, there's actually a few different ways. You could type Snyk auth. Don't do this, but you can type Snyk auth in an environment where you have a web browser. But since we don't have a web browser here in Cloud9, what we can do instead is Snyk auth and then type in your token right after that. Whoops, I thought I still had it on my clipboard. That's not going to work. Let me just get my token one more time. And then Snyk auth token, flash that on the screen. And it says your account has been authenticated. Snyk is now ready to be used. Okay, so that's all we need to do to authenticate with Snyk and install the CLI. In the next section, let's go ahead and move on. We're going to go back into Terraform Cloud, and we're going to create something called a run task. So our Cloud9 environment's all set. Let's go back into Terraform Cloud and create our run task. So this is going to be in our general settings, which, let me see if I can find it. Settings. And then, yep, so once again, that's just in your left panel, settings, and then run tasks. We don't have any run tasks, but we're going to go ahead and create one. And scrolling down, just like all these other steps, we need to give it a name because that's required. So we'll actually just go ahead and copy paste this since I have the button. Give it a name. And then for all of these other fields here, it's like it says endpoint URL, HMAC key. These might look a little daunting, but they're super easy to get. We're going to get those from Snyk. And once we do that, we'll have Snyk integrated with this Terraform run task. So leave the screen open. And then to get these values, what we then do is go over back to Snyk. And then in Snyk, under integrations, you can either scroll or search for Terraform. And we see that there's an integration between Snyk and Terraform Cloud. And if we click this, we get exactly those values that we're looking for. So this is going to be simple. We just copy and paste from the Snyk integration screen right here over into the Terraform Cloud run task. So copy and endpoint URL. That was the endpoint URL, right? Yes, it is. And then the HMAC key, we can actually copy this one completely securely without putting it on the screen, which is nice. And that's all we need to do. We could give it a description if we want. And then once all these are filled out, just go ahead and click create, and task successfully created. Okay, so I think that's pretty much it for the prerequisites. Congratulations if you made it this far. Let's get some hands emoji if you're still tracking. All right, saw one, that's great. Thank you. Seeing a few hands. I did actually throw up my hands. I know I'm not on video, but my hands are raised right now. All right, so on to module 1, Snyk and IAC. So in this module, we're going to get some code into our Cloud9 environment, Terraform code, of course, and then we're going to scan that code with Snyk to find where there are security issues. We'll do more than that, but that's how we're going to start. So first things first, let's get some code into our Cloud9 environment. And this is done through a standard git clone operation, and then we git clone, and then we change directory into that code that we just cloned. And just like before, it's really just copy paste. So since this command has these at the end, we can copy the whole thing and execute these all in order. So we clone the code, and then we change directory into this folder called vulnerable EC2, which we can see here. Yeah, now we've actually got some code in front of us. So now at this point, if you want, you can go ahead and open up some of the files that we just copied. And there's one important thing here that you're going to want to do is just double check in your AWS console which region you're in. In our case, we're in US East 1. But in the code that we just cloned, it actually says US East 2. So I'm going to go ahead and change that real quick. Make sure you do the same. And if you change it, make sure you hit Control S or Command S if you're on a Mac. I'm sure there's a setting to autosave, but you might get a little stuck if you don't save your file and get a little confused. So make sure you hit save when you make changes in here. Last step here is one more configuration in Snyk is to make sure that the Snyk command line knows which Snyk organization we want to use. This is pretty easy. So once you're in Snyk, you're going to be in your default organization. I named mine Team Hotel, H for Hashi. And the organization ID is, I'm already in the right place. It's in your settings, and just go to the general tab right here. And then you'll see organization ID right there in your general settings. And if we copy that and then type this command that we see on the screen, it's snyk config set org equal to the org ID that we have in Snyk. Org updated. Simple as that. Just make sure it's completely updated. Okay. All right. Next step is to run the Snyk CLI. So we've got some Terraform infrastructure as code in front of us, and now we want to scan this code and find where there might be security issues using the Snyk CLI. So we can do that with this command here, but we're already in the vulnerable EC2 folder. So I'll just go ahead and type what we normally use to scan infrastructure as code. It's Snyk IAC test. So Snyk is scanning our code, and just in a few seconds, it finished. And if we take a look at the results here, we see on the bottom some of the most relevant information, which is that we scan one file, it has issues. And if we look at the total number of issues, there are 0 critical, which is good, 0 high, also good. But we have 3 medium and 5 low severity security issues that we should address. So scrolling up, we've sorted these in reverse order, the most serious ones at the end, and not as severe issues further up. Now for this workshop, we're going to be focusing on the medium severity issues. So what we see is Snyk telling us that in our Terraform code, we've got a few things we need to look at, mainly security groups. So we have 2 security groups where it's saying that we are allowing inbound traffic from anywhere on the internet, which is a pretty easy trap to fall into when you're deploying infrastructure, and also definitely not a best practice because a lot of companies have corporate networks or VPNs where there are a specific set of IP addresses that represent that company. So what we should be doing here is restricting this to, let's say, the corporate, what's called a CIDR block, or set of IP addresses that belong to that corporate network. So the issue is we're just giving access to the whole internet to access our app here. Another issue is that we have a non-encrypted root block device. So in the world of computers, this is a hard drive. So we have a what's called an EBS volume in Amazon speak, and it is not encrypted. So we've got a hard drive plugged into our computer, and we don't have that data encrypted. So if someone were to somehow get access to that hard drive, they'd be able to read all of the contents without having to do anything special with encryption or passwords. So definitely a best practice to make sure that's encrypted. So going through the workshop here, we have reviewed these results. And now, let me just verify the next step. All right, so now the next step is to actually go ahead and provision this insecure infrastructure using Terraform. So to do that, we can actually scroll pretty far. This is what we're seeing on the screen is kind of a long description about how we can provision infrastructure and how Terraform works. Well, we can go down to this section to actually deploy this infrastructure file, this Terraform file. And to do that, we just type Terraform init to initialize our back end. Pretty common commands in the Terraform world, init, and then we run plan. All right, so our Terraform has been successfully initialized. Then we run, and I'll make this a little bit bigger so we can all see. Then we run Terraform plan. This doesn't actually deploy our infrastructure. Instead, it's going to look through all the code that we wrote and also look at our AWS environment and tell us, in this case, you see all these little green plus signs. What that means is that I didn't deploy anything, but if you proceed, all of this stuff in this list is going to get deployed. So we do want to deploy this. So let's go ahead and Terraform apply, and then we're going to add the auto approve flag here so that we don't have to.
I'll just add that at this stage, the Terraform run that we're doing is not integrating with Snyk, right? So we'll do that as in the next module. But at this stage, we saw Snyk provide the issues that are there with our infrastructure as code configuration, but we've gone ahead and provisioned it, as you see here.
Yep. Thank you, Yash. That's a good thing to call out. It's we did scan our code with Snyk, and we know there are issues, but we're intentionally deploying this vulnerable environment just to really prove that it's vulnerable. And again, we haven't connected Snyk to Terraform Cloud yet. We're very much running these independently. This actually isn't even using Terraform Cloud at this point, but once I hand it over to Yash in a little while, we will get that hooked up and you'll see the difference. Okay, so we have gone ahead and deployed our infrastructure, and I know it's creating a few things in the background, so let's actually go back over to instances and see. There we go. We have successfully deployed an EC2 instance, a really tiny one, a nano. Looks like our status check is still initializing, so it needs just a few more seconds until it's fully running. So let's go ahead and select this. Just like any EC2 instance, we can go ahead and click on it and get some more info about how it's running. We can also see that it has a public IP address. So let's go ahead and grab that, because remember what I was saying about these security groups and how Snyk was saying that they allow an open ingress. What that means, again, is that this instance is available for anybody, including all of you in the audience, to go and hit this EC2 instance. So if we open up our console again, what we should be able to do, assuming it's fully running, is attempt to SSH into that instance. SSH EC2 user at, and then we'll choose the IP address. And now what our console is saying is, hey, do you want to proceed and try to connect? Now we don't actually have the key to log in to this EC2 instance, so we don't need to, because the point is to show that anybody on the internet, including my laptop here, is able to access this computer in this AWS environment, and that's not the best practice. So I'll back out of here. And proceeding with the workshop, we can also, I'm not sure if this next command is going to work. We can try it, but just to prove that it's running, HTTP, not sure if we'll get it. Hey, it is. All right. This does take a couple of minutes, so if you don't see it, you can keep trying. But once again, we're just showing that anybody on the internet can access this app that's running in AWS, and we don't want that to be the case. So I'm going to go ahead and leave this infrastructure running. I'm going to skip this step because the workshop would take a little longer if I were to destroy and then recreate everything. So I'll leave it running. Now let's go back and fix our issues so that this is no longer a problem. So we can do this again using Snyk. So going back, let's go ahead and Snyk IAC test just to refresh ourselves on where the issues are. So Snyk is going to run another test. We're going to have the same results because we haven't changed anything at this point. But let's go ahead and get these fixed. So if you look at the code, we've put in some helpful comments here that start with workshop, and these are telling you where we need to make some changes. So first thing we're going to do is change this security group, which is like a firewall for the EC2 instance, so that it doesn't allow all traffic from the internet. That's what this means. But it instead allows only traffic from my personal IP address. Now, normally you would use like a corporate network or VPN kind of IP block here, but for the sake of demo, we'll just go ahead and use my personal IP address, which I can get. If I can remember, it's curl, so clear this, curl ifconfig.me. Now there's a few different ways depending on if you're on Windows or Mac to get this, and I think you can even run a search and say, what is my IP address? And some website will tell you. So get your IP address through whatever means necessary. And once you have that, let's go ahead and update this, which is, it's going to be your IP address and then /32. And if you know about CIDR blocks, that means that it's only this one right here. Scrolling down, both in the workshop and here in our code, we have another section because we have two security groups. We're going to make the same change here. By the way, one is for SSH access and the other is for HTTP access. We just used both of those earlier, SSH and HTTP. So I'll put my IP address here and we'll change this to a 32. And then scrolling down, let's go ahead and save this. We'll run, sorry, I'm just refreshing my memory here. Yeah, let's go ahead and run one more Snyk IAC test. Remember, don't forget to save, hit Control S in your file here before testing it again with Snyk. And now we can see, look at that. Now we don't have 3 medium severity issues, we have just 1. And to take care of that very last issue, we have down at the bottom of this file another workshop section. This is where we're creating our EC2 instance, and this EC2 instance, of course, has a hard drive so that it can run, and we want that to be encrypted. So to fix this security issue, we can either, well, we can do a little bit of both. We can read that Snyk is telling us that we should set root block device.encrypted to true, and then we can also see that we already have this code here. So you can uncomment the code, it's a command / to do that pretty quickly. And now that we've done all of that, we can Snyk IAC test and find that, like magic, we no longer, oops, how many times did I tell you all that we need to save the file before running a scan, and I'm a victim. So yeah, now that we run Snyk IAC test after saving, we should see, again, like magic, that we no longer have any medium severity issues. So just like that, we've secured our infrastructure totally free using Terraform and Snyk. And now, for just to show you what we would want to do is actually deploy this more secure infrastructure. So let's run Terraform plan again. And what we should find is perfect. So if you look at the Terraform plan when you run it again, after making changes to your code, what we're seeing here is that certain things are going to change in the infrastructure. We don't see just all green here. Instead, we see that some things might be removed, some things might be modified, and some things might be deleted after making these changes. For example, if we want to encrypt our hard drive, we actually need to replace it. So that's why we have a bit of a longer list here of things that need to change. But again, all we need to do is Terraform apply, auto approve, and that's all we need to do to deploy more secure infrastructure. So I'm going to let that run. In the next step here, what we're going to do is send results to Snyk, which is a pretty cool feature in the Snyk command line. So to do this, what we're going to do is let this finish. Should only take a few more seconds. And then what we're going to do is actually remove all of these changes that we just made to the file. So we're going to make it insecure again to show you how to upload your scan results into the Snyk user interface. So I'm going to give this just another second here. All right. There we go. That didn't take too long. Okay, so we applied, we've got our more secure infrastructure out there. Now at this point, we could go ahead and tear it down, but I'll come back to that in a little while. And please do tear down your infrastructure at the end of the workshop, just so we can save AWS some money here. Now again, in the next step, what we're gonna do is make this code insecure again, and we can do that by running these commands. So we could just check out the file again, which is this one, the main.tf file that we're working with. And now the magic Snyk command that we want to run is very similar to the one we did before. It's Snyk IAC test, but we're going to add an option there called report. So this is 2 dashes, -- report, hit enter. So remember, this is the vulnerable version of the code. We're scanning this. You could imagine that you might run a command like this in your CI/CD pipeline to not only scan your code and print results, but also send those up to the Snyk UI. And to visualize that, we can see report is complete. Your test results are available within your Snyk organization in the projects view. And to prove that, if we go to our projects, we have a new project. Normally, a Snyk user would say add projects like this, but if you're using the CLI, you can add them dynamically like this. And if we open it up, we see that Snyk tested our main.tf file just as we expect. It found the exact same number of issues as before, 3 mediums and 5 highs. And if we open this up, we find our Terraform project where we could add tags, which is useful if you want to do some reporting on this data later on. And just like the Snyk command line interface, we have a similar view here. It does look a little better than a terminal, I'll say, but it's telling us exactly what the issue is. In this case, it's saying, hey, you've got a hard drive that is not encrypted. It's saying what the impact of this is, which is if someone gets access to that, they can read all the files on that hard drive, and you can resolve it by doing exactly what we just did, which is making sure that encryption option is set to true. Here are the other two issues that we fixed. So we're already familiar with how to fix these. And by the way, if you don't believe what Snyk is telling you, or you have a better reason, you could, if you wanted to, ignore an issue and say something like, this is fine, maybe with the dog on fire emoji. But these are real issues, so we're not going to ignore them. We're instead going to fix them. So scrolling down, I think that's everything. As I said, we're skipping the optional exercise here. And next, we're going to do some more here. Again, we're sort of doing this in a disconnected way. We're using Snyk and Terraform independently of each other. But now that we have all these access keys and everything all set up, we're going to connect Terraform Cloud to Snyk and see how that works. So Yash, go ahead and take it away.
Yeah, thank you so much. I'll get my screen share going once more. And this time we're going to share the computer screen rather than the laptop. Give me just 1 second. All right. Hopefully you see something similar to what you were seeing on David's screen, where on one side we have our instruction set, on the left side that is, and on the right side we have what we're looking at right now is our Terraform Cloud workspace.
We do, yeah. Looks perfect. I think your screen's a little wider than mine too. Very nice.
Yeah, it is. I am on a wide screen. I hope that transmits okay. I'll like make the fonts bigger just to make sure it's easy on everyone's eyes.
Perfect.
Excellent. Okay, so what we're going to do at this step is configure Terraform Cloud. I know there were a couple of questions in chat, so I'll just mention it. You know, if you are creating, or when you created your organization, I'm just going to create one here, and you want to enable the trial. You need to enable the trial to enable run tasks, which is what we're going to use. Go ahead and click on this upgrade link over here and select the free plan. So this is, as David mentioned, this is valid for 30 days. So the free tier of Terraform Cloud doesn't include the run task capability. So you want the free trial enabled to do that. And then click Start Free Trial. And then at this point, you can continue with the rest of the steps that we're going to do. I already have another organization set up with the trial enabled that we will use for this purpose that has a few other things already set up. So in our Cloud 9 environment, we're going to check out a different branch of the repo that has the vulnerabilities that we want to address. We're going to run Terraform and we'll fix the issues and rerun the apply. So with that, let's jump in. We're going to create a variable set that for me already exists, but I'll show you how to do that. At the top level, if you click on settings and then you go into variable sets, we're going to create a variable set. As you see, mine already exists. It's called AWS credentials. But same thing, I'll show you how to create that. We'll click create variable set, call it AWS credentials. And then this is really important. You're going to apply it globally. In practice, you might apply it to a specific project, all the workspaces in that project, or to just certain workspaces. But for the purposes of our exercise today, we're going to apply it globally. And then we're going to create 3 variables. It's really important. You need to set these as environment variables, right? So we're going to have our AWS access key ID. Make sure you mark it as environment variable. You'll set the value, just demonstrating here. So I'll set it like this. And then you'll set your secret access key. Now, when you set this one, again, it's an environment variable, but make sure you mark it sensitive, right? What this will do is mark the value write only, meaning if you have permissions and you have full permissions in the workshop you're doing here, but through your RBAC role in Terraform Cloud, if you have permissions to set variables in this variable set, you'll be able to set the value, but you won't be able to see it, right? This protects sensitive credentials like your AWS secret access key, so that it's available for Terraform to use, but it's not visible to prying eyes. And then finally, the same thing for your AWS session token. So you're, of course, putting in your real values. This one, again, we want to mark sensitive. So we've added these 3 variables. And finally, we want to click the Create Variable Set button that actually generates that variable set that we have available. And as I mentioned, I already have it set in this organization that we're using, so you can see what that looks like. From here, we want to attach the Snyk run task that David had shown us how to create earlier to the workspace in question. So I'm going to click back up here at the top to workspaces. Here's my AWS Workshop workspace. I'm going to go into that workspace and then go into the settings for the workspace. And then we'll see here run tasks. So right now, there are no run tasks attached. I'm going to attach this available run task, which is Snyk run task for Workshop. And then as you see here in the instructions, we want to specify this run task to run post-plan. And what this allows the run task to do is leverage the output from the plan in examining what it is this workspace run is trying to do to validate that it is secure and compliant. And then the enforcement level we want to set is mandatory. So advisory is just going to give you a warning. It will not prevent you from proceeding. Setting the enforcement level to mandatory will make that check pass with all medium and high vulnerabilities addressed as we had configured it in Snyk, so that whatever we provision is compliant and secure. So I'll go ahead and click create. Great. So that run task is now configured for this workspace. Let's go on to the next step. All right, let me go back to my Cloud9 environment, which I have over here. I'm going to check out this vulnerable EC2, the TFC branch, right? And it looks like I'm already there. Okay, excellent. I want to go to, I believe I already have my Great. Okay. I already have that set, but otherwise you can set your Terraform token app Terraform IO environment variable over here. This will be your user token. It can also be a team token as you prefer, but it needs to have privileges to be able to do the run that we are going to do. I'm going to go ahead and open up main.tf. You can use VI certainly, but we'll just open it up in the code editor up here. And let me scroll to the top, and I'm going to set my organization name first of all. I can get that by going back to Terraform Cloud, and let me not confuse myself. I'm going to go ahead and close that one at this point. I want this right here is my organization name, so I can grab that and set it. And then the workspace that I created is AWS Workshop. I'll grab that value and I'll set it over here. I'm going to hit save so I don't forget. I'm also going to go ahead and change the region that we're working in to US East 1. So it'll look just like that. I just scrolled up. Okay. It's like, what happened? Okay, so let me do the Terraform init now. Now, we are working from the CLI, but we are going to have our Terraform run, in this case, happen in Terraform Cloud because of this Terraform stanza that we have here that includes the cloud stanza indicating where Terraform should execute this run. So Terraform Cloud actually supports 3 workflows. When we drew it out earlier, we talked about the VCS connected workflow, where when we create a merge request or merge that request or do a push, that triggers the Terraform run, right? That's the VCS connected workflow. Terraform also supports an API-driven workflow where, this is useful if you're having Terraform run from like a CI pipeline, right? Where you can use the Terraform Cloud API, the Terraform Enterprise API to do everything from creating the workspace to setting variables to doing runs and so forth. And finally, there's the CLI-driven workflow, which is super useful, for the developer persona as you're developing your Terraform code. The beautiful thing is that regardless of the workflow we're using, when we run Terraform, it's going to make sure that what we are provisioning or trying to provision is compliant. Let me go ahead and, as the next step, do the plan. And we can look at the output for the plan right here. It's going to display, but I can also look at it in Terraform Cloud. So let me take the URL that it's giving me, and we can actually open that up. So we have vulnerable code, right? That's the purpose of kind of showing this thing fail. It's designed to fail so that we can show you how you can correct the vulnerabilities that we have baked into this demo. So this is the plan that's running. This shows you what Terraform intends to do. So let me reopen that. Similar to what we looked at, in the CLI, right? The plus signs, the green plus signs indicate what Terraform is going to add. The minus red signs would indicate what Terraform is going to destroy as part of that run. And then you would see like a gray colored tilde, kind of that curly dash to indicate what Terraform is going to modify in place. And in terms of, Terraform deciding, is it going to create or destroy and recreate or modify in place, it will reflect what the Cloud API enables you to do. To give you a simple example, if you look at the history of the AWS provider and working with an EC2 instance, and you wanted to change the size of the EC2 instance, back in the day, that meant that resource would need to get destroyed and recreated. And now, a lot of the times, it means that resource can actually be modified in place, again, depending on what you're changing from and to. So our plan, you did see pass, right? We got a green check mark there. However, our post-plan step failed. And it shows us what failed, right? It was the Snyk run task for workshop step that failed. If I click on the details, that actually takes me to the Snyk console and shows me the vulnerabilities as David was showing us earlier, right? We have ingress security groups that are entirely too open. And again, we have a non-encrypted root block device, right? So the step we've done here is we've integrated the Terraform run with the Snyk run task enforcement. And you see that we're prevented from proceeding. The apply can't happen because our infrastructure definition is insecure, right? So let's go on to the next step. All right, and it wants me to actually try doing a Terraform apply. That will also fail, but we'll go ahead and run that and watch the failure happening. I'll just let it run here in the console, and while it's doing that, we'll go ahead and go to the next step and start working on fixing our issues. And the easy way to do this is you can just search for workshop, as David has shown us earlier, and it'll take you to all the sections where things need to be addressed. So just like David did before, I'm going to fix the CIDR block. I'm just going to, well, actually, hang on one second. Let me get my IP.
Yash, real quick,
Yeah.
would you mind making your main.tf file a little bigger? I think command plus.
Yeah, good call. Good call.
Yeah, perfect. Much better. Thanks.
Sorry about that. I would have been humming along over here. So here's another instance of. Now, in practice, you may go ahead and put in an exception, right, David, where you're saying, well, it's port 80. We want to actually, this is a public service, we want to make it available. So we would put an exception in that vulnerability in our Snyk dashboard. But we do want to encrypt that root volume. And then I guess this is the other one where, what did I call this? AWS Workshop. All right. So that is saved. And as you see, in the meantime, the Terraform apply we had run before did fail. So we've addressed the vulnerabilities that were identified. Let me go ahead and do the Terraform apply one more time. I could do a plan, but it's going to do a plan in the process. The auto approve won't require me to manually approve the run. It's also not necessary if you have the workspace configured to auto apply if everything passes. But let's go ahead and run it the same way. And this time I will go ahead and we can watch it in the browser while it's running. So as before, our plan indicating what this run is going to do. So the post plan this time did pass. And again, I can go look at the details if I like. And this time we see that there are 5 low priority issues, right? As there were before, but no more medium issues. So that's excellent. And because there's no medium or high issues, we proceed to the next step, which is the cost estimation. Now, the cost estimation that comes back, it actually shows you a breakdown of, we're just creating an EC2 instance, so what its unit cost is. But it would show you for all the different resources that we were trying to provision what the associated cost is. That can be fed into the next step, which would be the policy check. So if you wanted to enforce policies that control cost based on whether this is a development workspace or a QA workspace or a production workspace, you could do that. Since we don't have any policies configured, we actually go ahead and proceed and we do the apply. And here's the resulting output, right? And so if I bring my terminal window over here, and I try to say EC2 user at this, it does open up the connection, right? I'll go ahead and break. I don't need to actually connect. But there you have it. As a last step, it is always, it is always good to clean up after ourselves. So let me go ahead and do a Terraform destroy, and that finishes up this step of the workshop. I will give it from here back to David while our destroy runs.
All right, I think that's all we have. If the presenters want to hop back on for some final thoughts, we can. Looks like we're finishing just a little bit early, about 20 minutes. So if you attendees had planned to stay the whole time, we're pleased to give you 20 minutes back on your schedule. And if you're on the East Coast, we hope you enjoyed your lunch while we were doing this presentation. But yeah, thank you other presenters for doing this. Thank you all the attendees for joining. We hope you learned something out of this, how you can use best of breed tools to both deploy and also find and fix security issues in your infrastructure as code, and how you can leverage partners like Presidio and AWS to create these large-scale environments and also implement the policies and security at scale. So thanks again for joining. Any final words?
Final words. So you have access to this AWS account for next 24 hours. So feel free to learn something new, use resources as you need, and we'll be happy if you tell us that you learned something new and please some comments in the event survey, so we know what went well, what did not go well, so that we can work on it for the next webinar.
Yeah, we certainly appreciate your feedback. We just put the survey link in the chat, so please open that and be honest with us so that we can improve and do better next time.
All right. Thank you very much, all of you, for taking the time to share your expertise with us and go over Terraform and all the other parts of this workshop. Just a quick reminder for everybody, today's session was recorded. Following the panel, you'll receive an email with a link to access the recording on demand. You can also find the recording on devops.com and cloudnative.com/webinars. Look in the on-demand section. It'll be waiting for you there. As I mentioned at the beginning of the program, I do have 4 $25 Amazon gift cards. The winners are going to be Kieran C., Lane L., Sridhar E., and Mario G. Congratulations to the 4 of you. Please keep an eye out on your inbox to claim your gift card. If you don't receive it in your email, be sure to check your spam folder. Y'all, thank you again for taking the time to be with us today. Just want to thank all of our sponsors for today's Immersion Day. I want to thank each of you for attending in the audience. There is a short follow-up survey, another survey. If you don't mind taking that, it'll pop up right after this ends, just letting us know how we did and just give us your feedback. All right. I hope everyone has a great day. Thank you again for attending, and I am signing out.
Thank you all so much. Take care.
Thank you, everybody.
Bye-bye.